In this video, I will be going over Module 12.3, Geometric Series, and I am on page 613. So we're going to go ahead and read the definition of a series. So a series is the expression formed by adding the terms of a sequence. So I'm going to have you just watch for a moment, and I'm going to give you, let's give you the sequence 2, 4, 6, and 8. So this is a sequence, and a series is when you sum or add all of the terms. So I have 2 plus 4 plus 6 plus 8. So I have, let's see, this is 6 plus 8, 12 plus 8, okay. So I have 20. So for this finite series, I have, or finite sequence, I have that the series is 20. I added up each of the terms. And so that's what we're going to be doing. So let's go back to our Explorer. And we are going to talk about finite geometric series. So if the sequence is geometric and has finite number of terms, it is called a finite geometric series. In this Explorer, you will generate several related finite geometric series and find a formula for calculating the sum of each series. So let's see. If you start with a rectangular sheet of paper, assume that the sheet has an area of 1 square unit, and you cut it in half. So we're talking about just this half here. So we have a half, and here stage 2, or the next part, we have the half that we started with, and now we have a fourth. For stage 3, we have the half that we have that fourth we have, and then we have this right here, which is an eighth of the whole sheet. And so we have that half we started with, the fourth we had, the eighth that we had, and then this little guy right here is a 16th. So this is a geometric sequence because we have a half, then a fourth, then an eighth, then a 16th, and our common ratio is 1/2. We're dividing by 2 each time, or multiplying by a half. So it says complete the table by expressing the total area of the paper that has been laid out in 2 ways. So as the sum of the areas of the pieces that have been laid down and the difference between one and the remaining piece. So what they're talking about is this first picture was just a half. This second picture was a half plus a fourth. The third stage was that half plus a fourth plus the eighth. And that fourth stage was the half plus the fourth plus the eighth plus the 16th. The other one, or the other way they're saying, is by the difference. So let me switch colors. By the difference of 1. So for this, we had 1 whole sheet minus a half. Okay. Then we had 1 whole sheet in stage 2 minus a fourth. Right, that's a fourth of the sheet missing. Stage 3, we had 1 whole sheet minus an eighth. And in stage 4, we had 1 whole sheet minus that 16th right there. And so we want to complete the table. So a half plus a fourth, we have to get common denominators. I'm going to do this quickly. And we get 2, so we get 3 over 4, or 3/4 of the paper. We already know that this is 3/4, so then 1/8, let's see, 3/4 plus 1/8, that's also 6 over 8, so I get 7 over 8. And then here I have 7, this is 7 over 8, plus 1/16. So that's 14 over 16, so I get 15 over 16. And then if I do these over here, 1 minus a half is a half, 1 minus a fourth is 3/4, 1 minus an eighth is 7/8, and 1 minus 1/16 is 15 over 16. And you'll see that these values are equal. So there's two ways of looking at this. Now going on to the next page, write the sequence formed by the areas of the individual pieces that are laid down. What type of sequence is this? So we kind of already talked about this, where we had 1/2, 1/4, 1/8, and 1/16. And we said that this is geometric, and it had a common ratio of 1/2 each time you were dividing by 2, dividing by 2, dividing by 2. So let's go ahead and take this and look at what the explain on, let's see what page we're on. The explain on page 615 goes over. So explain 1 says finding the sum of the finite geometric series, and we have a formula, one that I do recommend you learn and memorize. There we go. And this is for the sum of a geometric series, requires knowing the values of a, r, and n. And I just want to point out that this is for finite, not infinite, but finite. So accountably many. So 5 terms, 12 terms, 8 terms, 100 terms even. That is a finite number. So let's see how we would do this. So let's look at A. And we have 5, 15, 45, 135, 405, and 215. And we could add up every single one of these and get our answer. Or we can use that formula that we were just introduced to. And let's write that down here. A times 1 minus r to the n over 1 minus r. So we know we need to find a, r, and n in order to plug them in. So the first term of the series is 5. So 5, I'm going to go ahead and erase this and put 5 in there. And then your common ratio, right? We take one of our terms and divide it by the other one. So if I take 45 divided by 15, I'm going to get that my r is 3. So I'm going to erase the r in this formula and write my 3 in. There we go. And then n. N is the number of terms. So how many terms do I have? 1, 2, 3, 4, 5, 6. So n is the number of terms. So right here, I should have a 6. And if you see, if we turn on to page 616 and continue this question, so we found our values, and then on the next page, we're going to go ahead and plug them in like we did there. And this is what we get. So when we simplify this, the sum of the first 6 terms, right, is 5 times 1 minus 3 to the 6th over 1 minus 3. So doing some simplification, 3 to the 6th power is 729. 1 minus 729 is negative 728. And 1 minus 3 is negative 2. So when I simplify my parentheses here, I get 364 times 5, which gives me 1820. Which I could have, back here, like I said, I could have just taken all these values, and just added them up, and I would have got the same answer. But when we look at part B, we don't know how many terms are included right there just yet, right? We know that we go from 1/4 to 1/8 to 1/16, and then some terms in between, and then all the way to 512. So what would we do here? Let's see. So we can find our first term, right? That's 1/4. We can find the ratio by taking 1/8 and dividing it by 1/4. And when we do that, we would freeze change flip. So I would get 1/8 times 4 over 1, which is 1/2. So my r is 1/2. And then I plug that into my formula. So my, sorry about that. My formula for a geometric series is f of n equals, sorry, a geometric sequence, right? We're talking about a sequence right now. We haven't started adding them up yet. is going to be a times r to the n minus 1. So that's what they did here. They took a and they said a is 1/4 and r is 1/2, and we have to the n minus 1. Now, if we know our last term, think about this. If we know our last term is 1 over 5/12, can't we set this equal to 1 over 5/12 and try to solve for n now? We only have one missing variable in this whole equation here. So let's see if we can solve that. So multiply both sides by what? So if I multiply both sides by 4, if I multiply by 4 here and I multiply by 4 here, that 1/4 cancels, and 4 over 5/12 is 1 over 128. And then we ask ourselves, 2 to what power is 128? So 128, I do know that 2 to the 4th is 16, so 2 to the 5th, 32, 2 to the 6th, 64, 2 to the 7th is 128. So I know that my exponent here has to be a 7, and so I have n minus 1 equals 7, so if I add 1, n is 8. Okay, so real quick, we found what a was. A was this. We found what our ratio was by taking 1/8 divided by 1/4, and we got 1/2. And then all we did was plug that into our geometric sequence formula and set it equal to the last term in order to solve for n. So now that we have this key information, which is a equals 1/4, r equals 1/2, and n equals 8, we can now plug it into our formula here. So let's go ahead and do that. A is 1/4, r is 1/2, and n is 8. So if we simplify, we get 1/2 to the power of 8 is 1 over 256, and 1 minus 1 over 256 gives us 255 over 256. And with freeze change flip here, where I'd multiply by a 2 over 1, the 2 and the 256, 2 goes into 256 128 times. So I'm going to get 255 over 128. And now I'm going to multiply straight across, and I'm going to get 255 over 4 times 128, which is 512. And so the sum of this series, 1/4 plus 1/8 plus 1/16, all the way until 1 over 512 is 255 over 512. So if we flip the page to 617, you have your turn 6 and 7. I'm going to just remind you to find a, r, and n, and then plug that into your formula, which is a times 1 minus r to the n over 1 minus r. Good luck, guys.